Welcome to an introduction to regression and correlation. In this video, we're going to focus on understanding the most common definitions that relate to regression and correlation. We will not be solving any problems in this video. Let's get started. Regression analysis is when we use modeling and functions to analyze the trend between the independent or explanatory variable x and the dependent or response variable y. In regression analysis, the goal is to fit a function to the data set. In regression analysis, we're looking for more of a trend rather than finding a function that will go through all of the data values. Real data is messy, and typically you cannot find one function that will go through all of the data points. There are many types of regression analysis: linear, quadratic, exponential, logarithmic, rational, radical. It really benefits to having a good understanding of the basic shapes of functions so that you understand what type of regression analysis you should do once you look at the data set. In this video, we'll be focusing on linear regression. Linear regression is when we use a linear function, such as y equals mx plus b, to analyze the trend between the variables. There's a wide variety of linear associations that we can consider. If you notice the two graphs on the very left, they tend to look more like a line. And as you look at the graphs from left to right, you see that the data points are definitely more spread out. In this case, we still describe them as linear association, even though they are not in a perfectly straight line. We're looking at a linear trend as opposed to a quadratic or exponential or logarithmic trend. Let's take a look at how we analyze the varieties of linear association that we can find. There are two main ways that we distinguish variations in linear regression. The first is by looking at the direction, and we always look at the graph from left to right. When we're looking at the direction, there's two possible ways. We could have a positive association, which is an upward trend from left to right, or negative association, which is a downward trend from left to right. We also like to take a look at the strength of the association. When we're looking at the strength, essentially we're looking at how tightly or loosely the data fit together. Let's go back to those graphs and let's compare and contrast both the direction and the strength of all of those graphs. First, let's take a look at the graphs and let's analyze the direction. Let's compare positive association versus negative association. The four graphs on the top all have an upward trend from left to right. So we would say that these four graphs have a positive association. The graphs on the bottom all have a downward trend from left to right. So we would say that these four graphs have a negative association. It's really important that when you're looking for the direction, you always have to look at the trend going from left to right. Now let's take a look at these same graphs, but instead let's look at the strength of the graphs. Strong graphs are when the data fit closely or tightly together. Weak graphs are when the data is more scattered. So with the graphs on the left, those graphs are very tight. In fact, they almost look like they're in a straight line. We would say that those two graphs have strong association. On the very far right, there's a lot of disbursement between the data points. We would say that those graphs have weak association. Looking at all of these graphs from left to right, I've placed them in an order where the strongest association is on the left, and then they progressively get weaker as you move from left to right. We use the correlation coefficient, which is represented by lower or uppercase letter R, to measure the strength and direction of the relationship between the independent and dependent variables. There actually is a formula that we use to calculate R, And you can see it's a pretty messy formula. We will always use technology, whether it be the calculator or Desmos or a statistical software program, to calculate R for us. What we need to do is understand how to use R. When we're using the correlation coefficient, the value of R will always range between -1 and 1. If R is greater than 0, this suggests a positive or increasing relationship. When R is less than 0, this suggests a negative or decreasing relationship. The closer the value is to 0, the more scattered the data will be. And the closer the value is to 1 or -1, the less scattered the data is. Let's go back to our 8 graphs. We said that the 4 graphs on top had a positive association. That would mean that R would be greater than 0 for all 4 of those graphs. R would not be the same because they have different values of strength, but R would be bigger than 0 since all of those graphs have positive association. Similarly, with the 4 graphs on the bottom, since they have negative association, R would be less than 0 for all 4 of those graphs. Now let's look at how R relates to the strength of these graphs. We said that the 2 graphs on the very left had a very strong association, whereas the 2 graphs on the right-hand side had weak association. For the graphs on the left, with strong association, R would be closer to 1 or -1. And the only difference between positive and negative would be related to their direction, as I just mentioned in the previous screen. For the graphs with weaker association, the value of R would be closer to 0. Let's analyze it a bit further. Let's just take a look at the 4 graphs on the outside. On the upper left-hand side, that graph has a strong positive association. And if you calculate the value of R, you'll see it's 0.964. Positive association means that R is going to be greater than 0. Strong association means that that value is very close to +1. On the upper right-hand side, this graph has weak positive association, and the value of R is equal to 0.134. R is positive because it's a positive trend or association, but it's close to 0 in this case because there is weak association between the 2 variables. On the lower left-hand side, this graph has a strong negative association. The value of R is equal to -0.955. On the far right-hand side, there's weak negative association, and the value of R is -0.234. Let's summarize. The correlation coefficient describes the direction and strength of the relationship between the 2 variables. Think of R as a timeline from -1 to 1. When R is -1, there is a strong negative correlation. The closer R gets to 0, there is either weak or no linear correlation. But then, as R gets closer to 1, there is a strong positive correlation. We'll take a closer look at R in later videos. This is just to get started. That's it for this video. Thanks for watching.